Now in the next problem, we're going to work with area. Find the area of the path shaded in the figure below by first measuring off a large rectangle as shown. The area of the path is going to be the area of the large rectangle minus the area of the smaller rectangle that we see here. So let's find the area of the large rectangle. We find the area of rectangles by multiplying the length times the width. So what's going to be the length of the large rectangle? Where we're going to have our 3 feet that's measured here going across plus another 6 feet. So we're going to have a length of 9 feet multiplied times our width, which can be found by looking at the 13 feet that's going across plus another 3 feet. So that's going to be 16 feet. We multiply 9 times 16 to give us 144. And we multiply our units, feet times feet, to give us square feet. So the area of the large rectangle is 144 square feet. To find the area of the small triangle, we're going to also use length times width. Our small triangle will have, we can think of its length as being 13 feet. Its width we can think of as being 6 feet. We're going to multiply those two values together to give us 78, and feet times feet gives us square feet. And now we're told to find the area of the pathway. We're going to take the area of the large rectangle minus the area of the small rectangle. So the area of the large minus the area of the small is going to equal 144 square feet minus 78 square feet, which is going to be a difference of 66 square feet, and that would be the area of the path. Let's look at how we can calculate the cost of a carpet. What will it cost to carpet a rectangular floor measuring 18 feet by 21 feet if the carpet cost $16 per square yard? Well, we're going to have to find the area of our carpet. We know that we can find area by taking length times width of a rectangle. So we have here 18 feet multiplied times 21 feet. However, notice that our cost is not given in square feet, instead it's given in square yards. So we're going to take our area and change 18 feet into 6 yards, as there are 3 feet per yard, and 21 feet into 7 yards, for the same reasoning. And so that gives us an area of 42 square yards. Now, since it costs $16 per square yard, we're going to find our cost by taking our area of 42 square yards and multiplying times $16 per square yard. Now, I've kept the units in here to point out that what's going to happen to our square yards is it will cancel out. We can now multiply the 16 times the 42 to give us our value of 672, and our unit of dollars is a part of our result. So the cost would be $672. Now here's another problem dealing with area, this time for a parallelogram. Find the area of a parallelogram with a base of 10 inches and a height of 6 inches. We're just going to quickly sketch this. We have a parallelogram, and we have a base that has a length of 10 inches, and the height, which would be from the base up, is going to be 6 inches. The formula for the area of a parallelogram is area equals base times height. So in this case, our area is going to be our base of 10 inches times our height of 6 inches, and multiplying our numbers gives us 60, and multiplying our units gives us square inches. The area is 60 square inches. Now here's another problem dealing with area, this time for a triangle. A sailboat has a triangular sail with a base of 12 feet and a height of 5 feet. Find the area of the sail. Well, we know that the area of a triangle can be found by taking 1/2 base times height. And we're given both of those units. So we're going to have our area equals 1/2 our base of 12 feet times our height of 5 feet We'll multiply 1/2 times 12, which is 6, times 5, which is 30, and multiplying our units together gives us square feet. So the area of the sail is 30 square feet. Next, let's look at finding the area of a trapezoid. Find the area of a trapezoid with bases of length 20 feet and 10 feet and height 7 feet. Our formula for the area of a trapezoid is area equals 1/2 h times a plus b, where a and b are going to be the lengths of the bases. So we'll substitute in our given values. Area equals 1/2 the height, which is 7 feet, times a base of 20 feet, plus another base of 10 feet. Now let's simplify. I'm going to leave this as 1/2 times 7 feet. Let's add within the parentheses. We have 20 feet plus 10 feet, which is going to be 30 feet. Then we're going to take 1/2 times 7 times 30. That would be 1/2 times 210, so that's going to equal 105. And then our units multiplied together gives us square feet. So the area of this trapezoid is 105 square feet. In our next problem, we're going to look at finding the circumference of a circle. Find the circumference of a circle whose diameter measures 10 inches. Express the answer in terms of pi, and then round to the nearest tenth of an inch. The formula for circumference that we can use is pi times d, the diameter. So we're given the diameter as 10 inches. Our circumference then is going to equal pi times 10 inches. And we can write that as 10 pi inches. That's the exact value. Now we'd like to round this to the nearest tenth of an inch. And so to do so, we can approximate the value of pi with 3.14 multiplied by 10, and we come up with our circumference approximately equal to 31.4 inches. Now let's look at the following application dealing with the trim around a window. A window has the shape shown in the figure. Suppose that the dimensions are 10 feet and 12 feet for the window's bottom and side respectively. How much trim to the nearest tenth of a foot is needed to go around the window? Well, if we think about starting here, we'd be going up this side and then around the top and then down and then back around in order to get that value. Notice that if we draw a line right here going across, what we see is that we have a semicircle at the top part of the window. So we're going to find the perimeter of this window by the following format. Our perimeter is going to equal, let's think about starting right here and moving around. We're going to move up, that's going to be 12 feet. We're going to add to that this length, which is going to be a semi-perimeter of the circle. That is a semi-circumference. So we're going to have 1/2 times pi times the diameter of that circle, which is going to be this width of the window, and that's going to be times 10 feet. Then we're going to add to that the 12 feet moving down, and then going across to where we started, another 10 feet. Now, let's simplify that. We can add 12 plus 12, which is 24, plus 10, which is 34. And then we're going to have 1/2 times 10, which is 5, times pi. So that's 5 pi. And we could even write that by taking our numbers, 34 plus 5 pi, and that would be how many feet we're looking at. Now that would be an exact value. If we're going to approximate, we're going to substitute in a value for pi of approximately 3.14 and simplify. So we multiply 3.14 times 5, add 34 to it, to come up with a perimeter which is approximately 49.7 feet. Now let's look at a common problem. That is, finding the better buy for a pizza. Which one of the following is the better buy? A large pizza with an 18-inch diameter for $20, or a medium pizza with a 14-inch diameter for $14. The better buy is going to be the one that gives us a lower cost per square inch. So that's what we're going to be determining, which means we need to begin by figuring out the area of each pizza, and then we'll figure out the cost per square inch. So let's start off with the area of the large pizza. We're going to figure this out by noticing that a pizza is going to be in the shape of a circle. We're going to have pi times r squared in order to determine that. In this case, the r is going to be 9 inches since the diameter is 18 inches. So we'll have pi times 9 inches squared, giving us pi times 81 square inches. And that's going to be approximately 254 square inches. Now that we have its area, let's figure out the cost per square inch. The large pizza cost us $20. So the cost per square inch can be found by looking at that fraction where we take $20 and we divide it by 254 square inches. Using a calculator, we come up with an approximate value of 8 cents per square inch. Now let's figure out what happens if we're working with a medium pizza. Let's start off in the same manner. We're going to find the area of the medium pizza by taking pi times r squared. In this case, we have a 14-inch diameter, so our radius is going to be 7 inches. That's going to give us pi times 49 square inches, and we can approximate that to get a value of 154 square inches. Now we'll find the cost per square inch, and we'll set that up by taking the cost of the medium pizza of $14, dividing it by 154 square inches, and we come up with a value that is approximately 9 cents per square inch. And since the lower cost per square inch would be the better buy, then in this problem, it turns out that our large pizza is better.